this is a projectile motion lab. This is a ramp, and this little dot represents a marble. We're finding final velocity for part 1. We already know that the initial velocity is 0, but we're trying to find this right here. So basically, to first start off, you have to measure the ramp in centimeters. And then you measure the total time with the timer in seconds, how fast the marble fell to over here. The equation we're using would be average velocity, total distance over total time. If you already found out the total distance and you already know the total time, you'll get an average velocity. Once you find that, you plug it into here. The initial velocity is 0, and the final velocity is unknown. You do the math, and then you'll get the final velocity. Part 2 is solving for the dy and the dx. The dy would be the height of the table, and dx is how far the marble went to hit the floor, which is x right over here. The y component would be how far the initial velocity for the y component is 0 because the marble stopped and then it fell off. So the initial velocity would be 0. Since you already know the distance from the table, which we measured the first time, you know that the initial velocity, like I said, is 0. So this would equal time. 0 times anything equals 0. So that cancels out completely. Then you do half AT squared. A is 9.8, which is acceleration due to gravity, and time squared. You do the math, whatever, and you get T. So then that would be your dy. So that would be the complete dy for the y direction. Then to find dx, you find dx equals average velocity T. Dx would be the range, and you find this by the average velocity. The average velocity you get from the first equation you did over there, and that answer you got you plug into right over here, and the time you plug in from here, so both of these equations are known. When you plug it in, you get dx, and that is a projectile motion lab. Goodbye.
So now, solve for dx.
Hey.